Alright, so for this video, we'll start discussing the paper 1, Pure Mathematics 1 paper for May-June 2024, paper 1-1. Okay, so we start with question number 1 here. First part, they want us to express this expression into the completed square form. Okay, so where A and B are constant. So we can start directly here. When you want to completing any square, okay, complete the square, right? Basically, you have to make sure that your coefficient of x squared or y squared is always a 1. Therefore, I factorize out the 3. Okay, so I must have plus something squared minus something squared. So the something here should be taking negative 4 divided by 2. So negative 4 divided by 2, you have negative 2. So you are trying to plus negative 2 square and also minus the negative 2 square. And then the constant term 15, I will not be affected. So I will just keep it outside the completed square form process. Okay. Next step, you need to combine the first 3 term here become a big bracket with a square outside. So the big bracket basically is having something with a square outside. So y square become a y. Negative 2 square, you have minus 2. Okay. For the last term here, inside the big bracket here, you need to square it out. So negative 2 square, you have a negative 15. So next step again, I have to multiply the 3 into the both term in the big bracket here. Okay, so what do I have? I'm having 3 and then y minus 2 square. 4 times 3 is negative 12, then minus 15. And end up, you'll be having this as your answer. Okay, so this is how we complete the square in a quadratic expression. All right, then let's continue to part B. For part B, hence, find the exact solution, highlight the keyword exact solution for this equation. 3x squared, 3x power 4 minus 12x squared minus 15 equals to 0. Okay, if you try to compare with what we have in the first part here, basically the coefficient is the same, 3, negative 12, and negative 15. Same thing happens here, 3, negative 12, and also negative 15. Just that the y has been replaced by x squared. So the y here has been changed by x squared here. Can you see that? Negative 12y become negative 12x squared. Okay, so that means what? That means if you want to solve this equation, you can use the completed square form here. So this is my completed square form, 3, and then y minus 2 square minus 27 equals to 0. Okay, equals to 0 here, so I put equals to 0 here also lah. Just that I cannot use the y anymore because I know that in this equation here, the y has been replaced by x squared. So I cancel off the y, I replace it by using the x squared here. And now they want us to solve this equation and get the exact solution. That means your final answer must be insert form or pi form or e form, but cannot be in a long decimal number answer. Okay. Alright, so first step, I try to move all the number to the other side. So I'll be having x squared minus 2 squared. 27 divided by 3, you get a 9. Okay, then next step, you try to take square root for both sides. You will be having plus minus 3. Okay, then after that, for x squared, you have 3 plus 2, which is a 5. Also negative 3 plus 2, which is a negative 1. Then when you want to take the value of x, you have to consider plus and minus sign for the square root 5. Okay, and also another one will be x equals to plus and minus sign square root negative 1. So I think the answer here is quite obvious because for square root negative 1, you'll get a math error, right? So there's no solution for this particular equation. So what do we have? So you're having the answer, which is x equals to plus, minus, and square root 5. Okay, so this is how we solve question number 1. Okay, so question number 2. The diagram shows 2 curves, and then one curve has the equation y equals to x, and the other curve has the equation y equals to fx. Okay, so in order to transform the graph y equals to sine x to the curve y equals to fx, the curve y sine x in the first reflected in the x-axis. So the first transformation is reflected in the x-axis. That means the up-down reflection. Okay, that means it is a reflection in the y direction, up down, right? Okay, so we need to know which one is the y equals to sine x first. So I think it's quite obvious. Y equals to sine x means this one. So this is y equals to sine x, and then the black color graph here will be the graph that after transform. Okay. All right. So first step is reflect the graph up down. No problem. Then after that, what they want, describe fully a sequence of 2 further transformation. So after the reflection, they want you to further write down another 2 transformation which are required. Okay. So before we can do any comparison for the original graph and also the final graph, it will be good if you can try to figure out, where is the center line of the original graph and where is the center line for the graph that is after transform. Okay, so if I have a look for the original sine graph, you know that the center line is always at the x-axis, which is y equals to 0. How I know that this is a center line is because of on top, above the center line, you'll be having 1 unit for the curve of sine x, and also below you also have 1 unit of the curve of the sine x. So if you have a look for the transform curve, right, where's the center line? So we can see that now the center line is, okay, 1, 2, 3, 4, 5, 6, 6 box in total. Therefore, the center line, I believe that should be at here. Okay, so this is the center line for the new graph, which is y equals to -2. Yeah, and then if you try to compare it with the original graph, you can see that the graph is having a larger amplitude, okay, from center line to the maximum point. It becomes 3 units because 3 boxes. So same thing happens here. From the center line to the minimum point, you are having also 3 units, which is 3 boxes. So that means you can see that there's a stretch in the y direction, because originally the total length or the total height for the whole graph is 2 units. And now the total whole graph, the length for the height for the whole graph is 6 units. Okay, so from here I can see that 1 become a 3. It is a stretch in the y direction with a stretch factor 3. Okay, so maybe I can write it out first. Okay, so the first one is stretch in the direction parallel to the y-axis. To y with a stretch factor of 3, which with a stretch factor 3. Okay, after that, after you stretch it, right, so your graph become longer, but you can see that the graph, the center line of the graph is still at 0. But after transform, the center line of the graph become -2. That means you're trying to move it 2 units downwards. Okay, so originally it is on the x-axis for the center line. Okay, then you are trying to move it downwards for 2 boxes. So that means 2 units. Okay, therefore the second transformation will be the translation. So what is the unit of the translation here with the vector of 0 and -2? That means you are trying to shift it 2 units downward. So these are the 2 further transformation that apply in our graph here from sine x to fx. Okay, and now they want us to find fx in terms of sine x. Okay, so how can we find fx in terms of sine x? So let's start with sine x first. Okay, when they try to apply the very first transformation, right, it is the reflection. Reflection in x-axis. So x-axis means x-axis is a mirror. So you reflect it upside down. Okay, so for upside down, that means positive become negative and negative become positive. So that means you are trying to multiply a negative outside your basic function. So negative sine x. So that's the first transformation. After that, the second transformation that we have is stretch in y with the stretch factor 3. Okay, so that means you have to multiply your whole equation with a 3. So you're having negative 3 sine x. So lastly, you're having a translation. And the translation here is you move it 2 units downwards. So move it 2 units downwards means that outside the basic function, you have to minus the 2. Okay, therefore, this will be your final answer after the sine x go through with all the transformation that is mentioned in the question. So this is your function fx. Okay, so this is the function fx that we have. Alright, yeah, so this is how we solve the. Okay, so question number 3. They are telling us that the coefficient of x power 3 in this expansion for the bracket here is 160. So they want us to find the value of the constant a. Okay, so basically this is related to binomial expansion. Okay, so if you already forget the formula, basically you can get the answer or formula from the formula booklet, which is this part. Okay, yeah, so you can just refer to it. And then for me, usually I just write out the simple term. So if you are going to expand anything, right, so it should be NCR. Okay, let's say I'm having a plus b, a plus b power n. So to expand it, you are having NCR, and then a power n minus r, then the b must be having the power r. So this is a general term when you want to expand any particular term for binomial expansion. Okay, all right, so now since they are interested in the coefficient of x power 3, therefore to expand this particular bracket with the power 6 here, I only focus on the x power 3. So I will be having 6c something, 3 power something, ax power something. Since I'm interested to have a power 3, right? So I want to set this as a power 3 here. Total power should be the 6. Therefore, the 3 must be also having the power 3. And then 6c, the value here should be a 3. Okay, follow the power at the back. Okay, then for this question, if you try to press calculator, 6c3 multiply with 3 power 3, you are having 540. And then the power 3 here, you have to multiply it to, you have to expand it inside the both a and also the x. So you're having a power 3 with x power 3. Since they tell you that the coefficient for x power 3, right? So the coefficient for x power 3 is this one, 540 a power 3 equals to 160. So from here, you can try to simplify the equation and get the answer for the a. So you need to take cube root. After you take the cube root, you will see that your a equals to 2 over 3. Okay, so this is how we get the answer for first part. Then let's continue to the part B. For part B, hence, they want you to find the coefficient of x power 3 in this expansion. Okay, so again, let's have a look what can we do if we want to get the x power 3 here. So first step, I try to put in the value for a, which is 2 over 3, and then x power 6. Then this one is 1 minus 2x power 1. The bracket with power 1, I cannot do anything to expand it because it remains as the power 1. It remains at how it looks like. Okay. And now, I need to expand this bracket, the first bracket here, so that when I take 1, multiply with something in this bracket, I get x power 3. Okay, so what is the something that I should include in my bracket here? So 1 multiply with something to get the x power 3. So the something here should be the x power 3 term that we have just now, which is 160 x power 3. So I put in 160 x power 3 here. Okay, then after that I have to take 2x multiply with something from the bracket to get x power 3 also. So the something here must be having x power 2. So that x power 2 multiply with x, I got something with x power 3. How can I get the term with x power 2 in this part? So again, I have to apply the general formula where it should be 6 c something, 3 power something, then 2 over 3 x power something. Okay? Alright, so this is not enough. So I have to make the bracket bigger. Right, multiply with 1 minus 2x. So like what I told you just now, 2x multiply with something with x squared. So I have to set this bracket here with a square. So I'm having 6c squared here. What's the power for the 3 here? It should be the 4. So that 4 plus 2, you get a total power of 6. Okay, so this is how we expand. Some students might want to prefer to expand everything, also can, up to you. Alright, but for me, I just focus on what I need. Okay, so I'm having 160x power 3. Try to simplify this second term here, 63, 3 power 4, 2 over 3 powers 2, and so on. By right, you'll be having 540x squared. Okay, so you want to multiply with the bracket 1 minus 2x. Okay, and now let's observe here. For the term number 1 here, you have to multiply with this one to get something with x power 3, right? So you're having 160 x power 3. Then for the second term is negative 2x. You need to multiply with this one, 540x squared, to get something with x power 3. So if you multiply them together, you're having negative 1080 x power 3. Simplify the term in x power 3 here, so you're having negative 920 x power 3. Okay, then again, if you read the question one more time, they ask you to find the coefficient of x3 only. So I only want to consider the number in front of x power 3, where the coefficient of x power 3 should be written as negative 920. Okay, so basically this is how we solve question number. We have question number 4 now. Okay, we are given y equals to fx, where fx is defined as this expression. The following point lies on the curve. Non-exact value has been given correct to 5 decimal places. So these are all the points that we have. We have A, B, C, D, E, F. And then you will see that A is 2, and then the x coordinate for B is 2.0001, which is very, very close to A. Then C is slightly further from point A, which is 2.001, but it is still very close. Then D, E, and F. F is 3, which is the furthest point, okay, from the A. So now they want us to find the value of K. Where's the K? It is this one, which is the y coordinate when x equals to 2.0001. So very easy. If you want to get the value for the K here, so K means what? K means you need to substitute 2.0001 into your function. Okay, so just substitute into the function. So 2 multiply with 2.0001, okay, minus the 1, then multiply with square root 3, multiply with 2.0001, okay, then minus 2 inside the square root, and then you have a minus 2 outside the whole function. Okay, then you just need to make sure that you use calculator to help it a little bit to get the value, and make sure you don't press it wrongly. So if you get the answer correct to 5 significant figure, 5 decimal places, it should be 4.00063. So that's a value for the K. Okay, so let's have a look for the second part, part B. For part B, they tell us that table shows the gradient of the chord AB, AC, AD, and AF. They want us to find the gradient of AE. Give your answer correct to 4 decimal places. So to find out the gradient of AE, we just need to use the both point, the coordinate for both point, and calculate it. Okay, so let's have a look. What is the point A and point E? E is this one, 4.63566. Okay, with 2.1, and then this one is 2 and 4. So you have to take y y2 minus y1 divided by x2 minus x1. Okay, so it is a very straightforward question. So y2 minus y1 means you're having 4.63566 minus the 4 divided by x coordinate is 2.1 minus the 2. So again, try to keep your answer correct to 4 decimal places, then it will be 6.3566. 4 decimal places answer. Okay. Alright, so if I fill in this gradient into my table here, so this is how my gradient of every single chord look like lah. Okay, and let's continue to part C. Part C, they want you to deduce the value of f prime 2 using the values in the table. Okay, so f prime 2 means that it is the gradient of tangent when the x is equals to 2. F prime 2, because f prime x means the gradient of tangent in other words, right? So when you substitute a value inside the f prime x, basically it means that it is a gradient of the tangent at that particular point. So this is the gradient of tangent. Gradient of tangent is equals to 2. So how can I know that what's the gradient for this particular point here if I don't want to carry out the differentiation? Okay, so you can actually observe it from the gradient of the chord that we have. Because if the point is very far away from point A, right? So you see that the gradient is 7 point something. And when all the point E, D, C, B, all the point here are getting closer and closer to A. So if you try to observe here, the gradient for every single chord here, when the point gets nearer to the point A, the gradient will basically getting closer and closer to one value. I don't know whether you can see it or not, but for the chord AB, you can see that all the value here is getting closer and closer to 6.25. And this 6.25 basically will be the gradient of tangent at x equals to 2. Okay, so this is what you can observe and you can tell them lah. So the f prime x will be equals to 6.25. Okay, so you can just try to observe all the value that is provided in the table so that you can see that, oh, this value is actually the gradient of tangent at x equals to 2 because A is the coordinate x with a 2. Okay, right? Yeah, so this is how we solve this question number. Okay, so question number 5. They want us to prove this identity. Okay, so I think it's quite obvious, yeah. We have to start from left hand side first, because left hand side looks much more complicated. Okay, so for the left hand side, I'm having sine square x minus cos x minus 1, then divided by 1 plus cos x. Okay, so how can I simplify my equation here? Okay, so first step, what I want to do is like, I want to get rid of the sine square x in my equation here. Okay, so there are many ways that you can make the sine square x disappear. So one of them is you can try to use the sine square plus cos square equals to 1 identity. Sine square x plus cos square x equals to 1. Okay, so if I'm having sine square x, I can rewrite it or replace it by using 1 minus cos square x. Okay, so that means the sine square x here, I want to replace it by using cos 1 minus cos square x. And minus cos x minus 1 divided by 1 plus cos x. Okay, so next step, I simplify 1 and negative 1. Then I factorize out the negative cos x. When I factorize out the negative cos x, the first term here, I left cos x with me. And then for this part, I have plus 1 with me. Then divided by 1 plus cos x. So I think it is quite clear that you can simplify these two bracket, top and bottom one, and eventually you get the answer, which is negative cos x. as what they want you to show. Alright, yeah, so this is how you get the proof, okay, for the identity here. Then let's continue further to part B. For part B, hence, solve the equation of this, okay, for x between 0 until 360. Okay, so let's start with the equation here first. I'm having sine square x minus cos x minus 1, then divided by, I saw a 2 here, right? So what I want to do is that I factorize out the 2 first, and then I'm having 1 plus cos x. So the purpose of factorize out the 2 is because I want to get exactly what do I have in my first part just now. I want to get this one. Okay, so to get what I have here, I need to factorize out the 2, and then it is equals to 1 over 4. Okay, so I try to move the 2 over. Okay, so I try to move the 2 over, then I'm having 1 over 2. Okay, then after that, you can see that, oh, this is basically what I have in the first part, and it can be written as negative cos x. So I try to replace it by negative cos x on the left, equals to half. It also tells you that cos x equals to negative half. Okay, then we can try to figure out what is our answer already. So first of all, we try to find the basic angle first. Basic angle will be cos inverse positive half. Well, basic angle always ignore the negative sign. Okay, so when you get positive cos inverse positive half, you'll get the value 60 degree, and this is the basic angle. Okay, and now I want to get the value of x. How can I get the value of x? So again, I have to go through the quadrant and see which part I should accept the answer. First quadrant, everything is positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. Then the fourth quadrant will be cos positive. If you want to get answer from first quadrant, the answer will be basic angle, which is theta. Answer from second quadrant is 180 minus theta. Answer from the third quadrant is 180 plus theta. Then this one is 360 minus theta. Theta here are basic angle, yeah? Okay. So if I have look for my equation here, I'm looking for cos negative. In which quadrant I will be having cos negative? So first quadrant, everything is positive, so I don't want to answer from this part. Second quadrant, only sine is positive, so that means cos is negative. I want to get the answer from here. So to get the answer from second quadrant, you take 180 minus the basic angle. So you get 120. Okay, so proceed to the next quadrant. So in the third quadrant also, you can see that, oh, cos is negative because tangent positive, so that means cos is negative. So to get the answer from this part, you take 180 plus the basic angle, which is 240. Okay, then the last one, cos is positive, therefore I don't want to answer from this part. Yeah, so basically this is how we solve the question number B, because it have go through one cycle, one round, from 0 until 360 degrees, so we should stop there. Okay, because our requirement for this one is 0 until 360 for the x. Alright, yeah, so this is how we solve. Okay, so we are now at question number 6. The function f is defined by this one, 2 over x squared plus 4. And then they only define it for x smaller than 0. Then the diagram here, it shows the graph of y equals to fx. So on the diagram, they want us to sketch the graph of y equals to f inverse x, show any relevant mirror line. Okay, so to sketch this graph here for f inverse, basically you need to know that what is the relationship between f and also f inverse. You should know that basically f and also f inverse, they reflect each other at the line y equals to x. So that means the mirror line will be y equals to x. Okay, so that's the first thing that you need to know. All right, so if you want, we can try to sketch the line for y equals to x first, so that you can imagine that it is basically the mirror, okay, the mirror of the graph here. Okay, so I do it also for this part. And I try to label it by y equals to x. Okay, Then if let's say you try to imagine, this is the mirror line, right? If you try to fold your paper, okay, fold your paper from here through the mirror line and to this side, you should try to imagine how will your, roughly how will your F inverse look like. This is your function F, okay? So you fold it through the line, then your function F inverse might look something like that, okay? But if you want to more confirm, then you can double check. All the steps here will not be given marks, I believe. All right, but it is just to for verify, okay? To verify or maybe to double confirm that your graph is correct graph. Okay, so I know that the mirror is y equals to x. Next one, I have a look for the value here. So this value here, the x, when x is getting closer and closer to 0, x is getting closer and closer to 0 from the negative part, okay, then you can see that your y is going up. When x getting closer to the y-axis, the value of y is getting larger. So now if I make a small conclusion here for this part, for my function f, okay, if let's say I'm having x is getting closer and closer to 0 from the negative part, you will see that y basically become a positive infinity. So that's the first thing. And the second thing, if I observe also for the function f, when x is going to be positive infinity, what happened to the y? So you try to imagine, if you try to substitute infinity into your equation here, 2 over infinity, you get a very small value, which is almost equals to 0. So 0 plus 4, you get a 4. And therefore, y is getting closer to the 4. Okay, so that means what? That means there's a asymptote here, basically, but you didn't see it. So there's asymptote here. Okay, and then this is basically y equals to 4. Okay, right. Then we want to sketch the inverse function, right? You need to swap the coordinate for x and y. Okay, basically the relationship between f and inverse is they reflect at y equals to x. Therefore, in terms of the coordinate for x and y, basically they are changing, they shift or they swap. The x become y and y become x, which means that if I'm having f inverse, according to what we have here, I have original function f, x getting to 0, y is infinity. So when I want to draw f inverse, it will become x getting to infinity, then your y is getting to 0 from the negative part. Okay, then same thing happen for the second part here. For f inverse, originally f is infinity, x infinity, y is 4. So now you swap the x and y coordinate. That means when x is getting closer to the 4, then the y will become infinity. Okay, so we are going to draw the green color part, okay, as a f inverse function. So again, for this particular line here, it is y equals to 4. So to sketch in f inverse, you need to sketch x equals to 4. So as the line for x equals to 4, it might be somewhere here. So I also draw as asymptote first. Okay, so this is a line for x equals to 4. So y become x, you can see that? Alright, and after that, now they say x infinity, positive infinity, y getting 0 from negative part. So that means when x is going to be infinity, your y is getting 0. So here, okay, something like that. Then when your x is 4, getting closer to the 4, y is infinity. Okay, wait, when x is getting closer to 4, y will be infinity. Oh, sorry, I think I make an error that just now, right? This one is not positive infinity, it should be negative infinity. Therefore, for this part, y also can be negative infinity. Yeah, so x getting closer to 4, y will be negative infinity. That means your graph will be something like this. So if you try to join them together, basically this is how your graph look like. Okay, and this is f inverse. Then you can double check again your graph by looking at the mirror line. If you try to flip the mirror line, so this is roughly how your graph will look like. Okay, so this is how you get the answer for part A. Yeah, so again, the basic one is you just need to know that they reflect at the line y equals to x. So if you want, you can just fold the graph and you imagine. If you need more points or more reference point to help you and sketch the diagram, then you can consider some relation between the x and y for the function f and also f inverse. Right. And again, all the mark score here will not be given any mark. All the step here will not be given any mark. This is for reference. Right. Okay. So let's have a look for part number B. They want you to find an expression for f inverse. Okay, so to find the expression for f inverse, first step usually I will let y equals to function f. So I'm having 2 over x squared plus 4. So this is y in terms of x and now I want to change become x equals to something something y to make it become the inverse function. So I bring the 4 over. Okay, and after that I'm having x squared equals to 2 over y minus 4. For the function x, I need to take square root. Okay, when I take square root, I need to consider the plus and minus sign. Right, so here actually tell us that we are having two possible answers. One is square root, positive square root something. Another one is negative square root something. Okay, so which is the correct function that I should choose? So again, this is the range. All right, this is the range of the inverse function. So you need to know that the range of the inverse function should be equal to the domain of the function. So to choose the correct range, you look at the domain. So the domain here tells you that it is x smaller than 0. So for x smaller than 0, right, which function will give you x smaller than 0? Which function will give you negative value? Positive square root something will give you negative value, or negative something will give you a negative value. So I think the answer is very obvious, right? This function will give you a negative value, smaller than 0. Therefore, your answer for f inverse will be equals to negative square root 2 over x minus 4. Right, so basically this is how we decide and get the inverse function for this question. Okay, so you cannot leave this as both of this as a final answer. Cannot, you have to choose one which is the correct one. So we are using the idea about the inverse function range equals to the domain of the function. Right? Okay, so let's continue further for part number C. Now they want you to solve the equation fx equals to 4.5. So again, I think it is also very straightforward. Fx equals to 4.5 means that you substitute 2 over x squared plus 4 equals to 4.5. Okay, then eventually you will get x squared equals to 4. And after that, you are getting x equals to plus minus 2, right? Because when you take square root by yourself, you have to include the plus and minus sign. Okay, then should I accept both as answer or should I accept only one answer? So since in the question itself, they did tell us that x, I only want to consider the domain smaller than 0. Which means that for this answer, I only accept the answer which is smaller than 0. Therefore, this is the correct answer for this question. Okay, and after that, they are asking, explain why the equation fx equals to f inverse has no solution. Okay, so if you have a look for the diagram here, I think it's very obvious. You can see that the function f1 is on this quadrant. Function f inverse is in this quadrant. And basically, they won't intersect with each other. When they didn't intersect each other, that means there's no intersection point. There's no also solution when you are having f inverse equals to f. Okay, so you can just tell them that the graph f inverse and f not intersect. So you won't get any solution, okay, when you let fx equals to f inverse. Right? Yeah, so this is how we solve question number 6. Okay, so question number 7. In the diagram, they are telling us that AOD and BC are two parallel straight lines. So you can see that BC and AOD are straight line. Arc AB is the part of a circle where the center is O. Radius is 15. Angle BOA is theta. So they are trying to explain what we have in the diagram. The arc CD is a part of the circle with the center O as well, and the radius is a 10. Angle COD is half pi radian. Half pi radian means 90 degree lah. Okay, so for first question, they want you to show that theta is equal to 0.7297, correct to 4 decimal places. Okay, so to show the theta, right, maybe I want to use this triangle to help me. Because if let's say I'm having some triangle that involve the trigo ratio, right, that is easier for me to get some answer for the theta. And you know that for this triangle, right, it is next to the theta that we want to find. So what is basically this theta here? I know that this angle is 90 degree at the side. So this whole thing is also 90 degree. And the angle inside the triangle will be pi over 2 minus 90 degree. Oh, sorry, minus the theta. Okay, so I'm using this angle to help me, yeah? And after that, I know that 15 is the radius of the sector BOA, right? So OB and OB, OA and OB, okay, basically it's having the same length because they are both the radius for the circle. Okay, then after that, what happened to the OC? OC and OD should be the same because they are both the radius of the circle as well. So it is 10. And I think it is quite obvious that from here, if I want to use the trigo ratio for this triangle, I can use cos. The angle is pi over 2 minus theta. If I get cos pi over 2 minus theta, what do I get? I will get 10 over 15. Adjacent over hypotenuse, right? 10 is the adjacent, so 15 is the hypotenuse. Okay, then after that, you try to get the value of cos, the theta. So you'll be having cos inverse 2 over 3. Okay, then theta equals to pi over 2 minus cos inverse 2 over 3. Okay, then what do I get for the theta? So you just try to press calculator, make your calculator in radian mode. Okay, then by right, it should be no problem for you to get 7297. Correct to 4 decimal places, like what they want us to show. Okay, yeah, so this is how we prove. Okay, all right, then let's continue further. Part number B, they want us to find the perimeter and also the area of the shape ABCD. Give the answer correct to 3 significant figures. Okay, so now we want to find out the perimeter and also area. So let's have a look for the diagram again. Yeah, right, so maybe to refer you, I try to free screen a diagram here. So we can refer to this diagram straight away. Okay, so let's have a look for the diagram. It is a bit small, but you just need to refer it a little bit, yeah? Okay, so to find the perimeter, how to find the perimeter? So basically, you need to add all the length for different part. Okay, so let's start with perimeter first, yeah? Okay, for perimeter, I'm going to use the length AD plus BC plus the arc AB, then plus the arc CD. Okay, AD is very straightforward. They are 25. BC is also very straightforward because how to get the BC? Yeah, it is the length of one of the side for the triangle, right? You know the hypotenuse is 15. So you take 15 square minus the adjacent length with the 10 square and square root. So for BC, you need to use the Pythagoras theorem to find it out. So 15 square minus 10 and you square it. How to find the arc AB? So the arc AB, I have to use R theta. R is 15. Theta will be 0.7297, where it is the answer that we find in the first part. Okay, because for this question, yeah, they already asked us to prove that theta is 0.7297, right? That means for the calculation in any part later, you are allowed to use this particular value, 0.7297 in your calculation. Okay, so this is the arc AB. Then plus, what is next? Next is the arc CD. So for the arc CD here, if you are aware, you can see that it is the quarter of the circle. How to find out the quarter of the circle? Okay, so you can use 1 over 4 multiplied with 2 by r. Then some students, they just want to directly use r theta also. So if you want to use r theta also can, where r is a 10, your theta for this part is pi over 2. Okay, yeah. Then after you write out everything here, then you just try to get the answer lah. So if you press calculator, by right, you'll be getting an answer like this lah. It's a long value. Then the question already requests, right, asks us to correct it to 3 significant figures. So your final answer should be 62.8. So that's how we calculate the perimeter. Okay, all right. Then next one. Besides the perimeter, they also want us to find out the area. So how can I find the area for this one? Okay, so let's start. To find the area, I want to use the area of this sector, OAB, sector OAB, or AOB or whatsoever lah. Okay, then plus the area of the triangle BCO or BOC, then plus the quarter circle. OCD. Okay, so put in all the value that we know. Sector AOB means half r square theta. Half r square theta means that I'm having half. R square is 15 square. Theta is the value that we get just now, 0.7297. For the triangle BCO, I take half times base. One of the base is square root 15 square minus 10 square times height. So the height will be the adjacent length, which is 10. Okay, then quarter circle. So what's the area for a quarter circle? For a circle, it is pi r squared. So pi r squared. Then quarter circle means I have to divide it by 4. So 1 over 4 pi r squared. Okay, then again, after you write out all the formula here, you just try to press calculator to get the answer. So this answer should be a long one. Okay, then of course we have to correct it to 3 significant figure where it will become 217. Okay, so this is how we solve question number 7. Okay, so we are at question number 8 now. The first three terms for arithmetic progression as shown like this. There are 3 terms here where p is a constant. Find the value of 10 term of the progression. Okay, so first of all, since we know that the first 3 term of arithmetic progression is as shown here, for arithmetic progression, we know that if I take the second term minus the first term, I will get a D. Okay, if I take the third term minus the second term, I also get a D, where both the D here is the common ratio that the value should be the same. Right, so by using this concept, I'm going to find out the common difference. So for p minus 1 minus the previous term, which is 25, it will be equals to third term, 30 minus p, minus the second term, which is 4p minus 1. Okay, so by trying to simplify all this equation here and also try to group all the p to one side. Okay, so by right, you should be having 9p lah. So 9p equals to negative 26, become 26 plus 14, which is 40. Okay, so from here, you get your p. P is equals to 40 over 9. Right? And for this question, they want us to find out the 10 term. So to find the 10 term, it will be T10. Okay, so formula for T10, what is the formula for T10 basically? So it should be A plus n minus 1D, right? Okay, so what is your A? A is 25, first term, plus n minus 1, it is a 9, and D. Okay, so now what is my D here? So to get the D, you have to take 4p minus 1 minus 25. So 4p minus 1 minus 25. This is your D. Okay, so just try to use calculator to help you a little bit. If you didn't do any careless mistake, by right, your answer should be negative 49. Okay, so this is how we solve this equation, this question. Right? Yeah. Then let's have a look for part number B. Okay, for part B, what do we have? For part B, now we are having the first three terms of a geometric progression is shown like this. And then Q is a positive constant. Find the sum to infinity of the progression. Okay, so when you're having a geometric progression, right, you need to know that the common ratio R is basically taking the second term divided by the first term. Second term divided by the first term. It can be also the third term divided by the second term. Okay, so I'm using this result here. I will have 4Q minus 1, which is the second term, divided by the first term, which is 25, equals to third term, 13 minus Q divided by the second term, 4Q minus 1. Okay, so I will be having 4Q minus 1 squared equals to 25 multiplied with 13 minus Q. Okay, so from here, we expand everything and try to solve for the Q. So I'm having 16Q squared, 8Q plus 1. Okay, then after that, you take 25, multiply with 13, you're having 325, then minus 25Q. Okay, simplify the equation. By right, you'll be having 16Q squared, then plus 17Q minus 324. Then from here, I try to factorize it. So maybe you can use calculator to help you. Then you try to factorize it out. So by right, you should be having this bracket equals to 0. And you will get two values for the Q. Q is negative 81 over 16. Another one is Q equals to 4. And I think it is quite obvious that we have to ignore the negative value of Q because in the question, they did tell us that, oh, Q should be a positive value, right? So we accept only the Q, which is equals to 4. We accept the positive value. Right? And this is not my final answer yet because for this question, they were asking, finding the sum to infinity for the progression. Alright, I want to find out the sum to infinity. Before I can find the sum to infinity, maybe I need to find the R first. What is the common ratio? So common ratio is 4Q. 4Q means 4 times 4 minus 1 divided by 25. And from here, you get your common ratio 3 over 5. Then only you start finding out the sum to infinity. The formula is A over 1 minus R. What's my A in this case? It will be 25. And then you take 1 minus 3 over 5. Try to simplify it and you'll be getting the answer 125 over 2. Okay, so this is how we solve question number. Okay, so question number 9. The diagram shows part of the curve with this equation and the line 2.4 and also y equals to 1. The curve intersects the line y equals to 1 at the point 1, 1. Find the exact volume, highlight the keyword exact volume, of the solid generated when the shaded region is rotated 360 degrees about the x-axis. So my final answer should be in exact value, yeah? Okay, they are talking about volume. Right, so in general, the volume formula is you have to do integration, you have to use integration, then pi y squared dx. If the shaded region rotate through the x-axis, right? So you should integrate towards the x dx. Okay, so in general, the formula of the volume should be integration of pi y squared dx. Okay, so before we can substitute all the equation into my formula here, we need to analyze a little bit about the steps that we need to find out. Okay, so for your information, we can find out the integration or we can actually find out the area by using integration, but the area is area under the graph. Same thing happens for the volume as well. So the volume will be volume under the graph. Okay, all right. So if you have a look for the shaded area here, this shaded area is basically above this curve, above the curve. Okay, therefore, to find out the shaded area for this part, you actually need to take the rectangle here minus the area at the bottom. Then only you get the shaded area. Same thing happen for the volume. If they want you to find the volume, you have to find out the volume generated by this rectangle first, then minus the volume generated by the area below. Then only you can get the volume on top for this part. Okay, alright. Since this whole part here, there's nothing involved, so I will just ignore this part. I will want to start from this particular dotted line here. So for this particular dotted line, you know that the value of x is equals to 1. Okay, alright. And now you want to use the volume generated by this horizontal line. The volume generated by this horizontal line is having y equals to 1 at the equation. So if I try to find the volume generated by this particular line minus the volume generated by this curve, then I will get the volume by the shaded area. Okay, so this is what we plan to do lah. Okay, so let's start to set the question now. Okay, so to get the volume, like what I told you just now, we need to have integration of pi y squared dx. So maybe the first y squared dx here denotes the horizontal line. Okay, then I want to minus another pi y squared dx, where this second pi y squared dx here denote the curve. Okay, because if I integrate pi y squared for this particular curve, the volume that I get should be this one. Okay, alright. So let us start. Okay, for integration part here, both term got pi, so I prefer to take it out. Okay, and for both term here, the limit start from 1 until 2.4. So the integration limit will be 1 until 2.4. This is where your area start and where your area end. Okay, so for the first y square, I want to substitute the equation of y for the horizontal line. So this horizontal line, the y is equals to 1. So you're having y square means 1 square. Minus, you copy the minus. For the second y here, okay, I want to substitute the equation for this particular curve. So this particular curve, the equation is y equals to 5x minus 4 and then power negative 1 over 3. You bring up, so it becomes power negative 1 over 3. Okay, so if I substitute into my integration, it should be y. Y means 5x minus 4 power negative 1 over 3, and I want to square it. So this is 1 square minus the second y square. First y square minus the second y square. Okay, so this is how we set up the step. Alright, then slowly we need to start the integration already. Okay, before we start the integration, just let us try to simplify my expression first. 1 square is a 1, nothing special. Okay, then when we are having power, outside another power, basically we are going to multiply the power together. So I have to multiply the power together first, which is 2 over 3 negative, before I can integrate that. Okay, then after that, I start the integration. So I'm having pi. Integrate the 1, I'm having the x. Integrate 5x minus 4, this power, you need to take power plus 1. Power plus 1 become 1 over 3, divided by the new power, which is also 1 over 3. After that, you have to differentiate the thing inside the bracket, you get a 5. Then you put in the limit 2.4 and also 1. Okay, so what's next? Before I substitute in the limit, again, I prefer to simplify all my value first. So 1 over 3 multiplied with 5, you get 5 over 3. 1 over 5 over 3, you get 3 over 5 here. Okay, so after you simplify it, this is how your expression look like. Then you put in 2.4 and also 1. Okay, so now let's substitute in the value one by one. First, substitute in 2.4 first. So you're having 2.4 for the x. Minus 3 over 5, you just copy it. Okay, then you take 5, multiply with 2.4 minus 4. Okay, then I think you should get 8. So 8, you take the cube root of 8, you'll be having a 2. Okay, then minus, now you want to substitute in the 1. So substitute x equals to 1, you have a 1. Minus 3 over 5, you just copy. 5 minus 4, 4 is a 1. So 1 cube root also a 1. Okay, yeah. Then again, further simplify all the terms that you have in this part and make sure you don't do careless mistake. Okay, so simplify all the terms here, all the numbers here. By right, you will get this one, 4 over 5 pi. Because they're asking for exact volume, so I will just keep my answer in this form, in the pi form. Alright, so this is how we solve question number 9. Question number 10. The equation of a circle is this one. And then there's a line with y equals to mx plus c, pass through the point 0 and negative 9, the tangent to the circle. Okay, so for this particular sentence here, if you want to sketch out the diagram, right, it might look something like this. That means you're having a circle, and then there's a line, which is y equals to mx plus c, pass through the point, and it is the tangent. So that means this is the tangent of the line, tangent of the circle, sorry. So for this tangent of the circle, right, the equation is y equals to mx plus c. And if this particular line pass through 0 and negative 9, so 0 and negative 9 should be somewhere here. Okay, then now they are asking, find the two possible values of m. For each the value of n, find the coordinate of the point at which the tangent touch the circle. Okay, so we are going to find the m. So where is the m? M is basically the equation of the line, right? So first step, since we already get the value of 0 and negative 9, that means 0 and negative 9 pass through the line equation. So what I can do now is I can substitute the point into the linear equation so that I get the value of c first. Okay, so y equals to mx plus c will become what? Y equals to mx plus c will become negative 9 equals to 0 plus c. And therefore your c is equals to negative 9. That means your linear equation here is y equals to mx minus 9. Okay, and now since they say that the line equation, the line here is a tangent to the circle, so that means when you want to substitute your line into the circle, right, the curve and also the line touch at one point, so the keyword is also the tangent. Tangent is also one of the keyword. That means later when you substitute your line equation into the curve equation, you can apply the concept for discriminant b squared minus 4ac equals to 0 because they touch each other at one point only. Okay, so let us start. I want to substitute this equation into circle equation. Okay, so what is the circle equation here? X minus 3 square, then plus y square. So your y square I substitute directly using mx minus 9 and then square equals to 18. Okay, then try to expand everything carefully. Okay, so you can see that this is what I have, and now I want to group all the x squared together. So I factorize out the x squared from all the term of x squared. So I'm having 1 plus m squared, then bracket x squared. I also want to group all the term with x together. So I'm having negative 6 minus 18m. Factorize out the x. And then simplify the constant term. I'm having 72 equals to 0. Okay, so you can see that I'm having a quadratic equation in terms of x. And since I know that the curve is a tangent to the circle, therefore, I can use the concept of discriminant, where b squared minus 4ac is equals to 0. So substitute b, negative 6 minus 18m squared minus 4. Your a is 1 plus m squared and the c is 72. You let it equals to 0. Okay, then again, try to expand all the square here. Make sure you don't do careless mistake. Okay, then eventually you need to go through with a few more steps of simplify them. So eventually you will get the quadratic form equation in terms of m. So m squared plus 6m minus 7 equals to 0. Okay, so you can see from here that basically you can factorize them. So m minus 1, m plus 7. Okay, so from here you are getting two values for m, so which is m equals to 1 and also m equals to negative 7. Okay, so after you get the value for m, what they want. So let's have a look for the question again. Find the two possible values of m. So you find already lah. Then for each value of m, find the coordinate. That means they want you to find the value for x and also the y. Okay, so now by using these two these two values for the m, we want to find the coordinate for x and also the y. So how can we find it out? So I'll write out here. Okay, for m equals to 1. Substitute m equals to 1 into my quadratic equation here with the m. So 1 plus 1 here, you're having 2. So 2x squared. Okay, then simplify, you're having negative 24x plus 72 equals to 0. So you substitute m equals to 1 into this equation. And this is what they can give you. Simplify further, you'll be having this. Okay, then from here, you realize that you can actually factorize out. So you get x equals to 6. When you get x equals to 6, you can further find out the value of the y. So how can I find the y? So to find the y, substitute it into this equation, linear equation, mx minus 9. So m for this case is 1, x is a 6, then minus 9. And from here, you get your value of y, which is equals to negative 3. So this is first set of the answer for the m. Okay, after that, we are looking for second set. When your m is equals to negative 7, what is the coordinate for the x and also the y? So same thing happen, substitute negative 7 into this particular equation here so that you can use it to solve for the x. So I'm having 50x squared plus 120x after you substitute them and also plus 72, then you get a 0. Okay, then please try to further simplify it. By right, you'll be having 25x squared, then 60, and also 36. So to simplify or factorize this one, you should have 5x and 5x. You should be having 6 and 6. And both are positive. Okay, so here, x equals to negative 6 over 5. Then again, substitute into the y equation, it is mx. So m for this case is negative 7. X is negative 6 over 5. Okay, then minus 9. And therefore, your y value for this case should be negative 3 over 5. Alright, so after I successfully get the value for the m, successfully get the value for all the coordinate of x and y, then I rewrite my final answer again. Okay, so for my final answer, you need to know that I'm having two set of answer. When m equals to 1, then your coordinate for the point is 6 and negative 3. Then when m equals to negative 7, then your answer for the coordinate will be negative 6 over 5 and also negative 3 over 5. Okay, so this is how we actually get the answer for this question number 10. Okay, so we are now at question 11. There's a function defined like this, yeah, and then the graph of y equals to fx is shown in the diagram. So they give us a diagram for the particular curve here. And first, they want us to find the set of value when fx is decreasing. Okay, so highlight the keyword fx is decreasing. When we are talking about function decreasing or function increasing, right? Basically, we are looking at the range, the gradient of the tangent. That means if let's say your tangent is increasing, that means your function is increasing as well. So if let's say your tangent is going up, That means your gradient of tangent is positive. And now they're looking for fx decreasing. That means your gradient of tangent should be negative because of decreasing. Okay, so we need to think about this. So dy dx negative, or we let dy dx smaller than 0. We are looking for the part where the dy dx is smaller than 0. So this is what we want to do for this question. Okay, so let's start with the function first. We are given the function here. I will change it become the pattern that's easier for differentiation. Okay, so first we differentiate it. Okay, so copy the constant power, you move it in front, become a number. Then copy the x power minus 1, become -4. Simply happen for the second term here. Copy the constant power, you put it in front, copy the x power minus 1, become -2. Differentiate the constant 2, you get a 0. Okay, then I try to simplify this term here. I'm having -12 x power -4, and also +3 multiplied with x -2. Okay, so they are asking for in which part of the function fx is decreasing. Okay, so I'm going to look for dy dx smaller than 0. But before that, right, I want to have a look for my diagram here. I think the diagram actually provides us some very useful information to solve this question. If I look at the diagram, right, you should know that our decreasing function will appear usually before, how to say, usually it is around the stationary point one, because before and after the stationary point, right, the function will usually change the pattern. If let's say before the stationary point it is increasing, then after the stationary point it will be decreasing. Simply happen if let's say on a particular stationary point, right, before the stationary point it is decreasing, then after that it will be increasing, right? So what are we going to do now is, if you look at this particular diagram, I think it is quite obvious that we know these two parts of the curve of the function is decreasing. This is one of them, and another part is this one. Okay, all right. So these two parts that I highlight, one will be the decreasing function. Okay, and now I want to know what is this particular stationary point here. I want to know what is the particular stationary point here. So to know these 2 points here, these 2 points we call a stationary point. That means it can be either the maximum point or minimum point, right? So how we find out the x coordinate for the stationary point? Basically, we will let f prime x equals to 0 first. Okay, so I let it equals to 0 first. Then I try to solve this f prime x equation. Right, so what do I have from here? If I try to simplify them, I will be having this 3x squared minus 12 equals to 0. Then I can factorize out to 3. Then if I continue further, I can get further factorization, which is minus 2 and x plus 2 equals to 0. Then from there, I will get x equals to 2 and also x equals to -2. Okay, therefore, you know that these two particular stationary points have the x coordinate. This is -2. This is +2. All right, and from the diagram here, you can see very clearly that the red color graph, the red color part of the graph here belongs to the decreasing function. And from the diagram, I can directly tell you the answer. I can directly give you the answer. Okay, so how should I give the answer is, from the graph, right? So you can see that the fx, the function f is decreasing from -2 to +2. Okay, but if you try to observe, there's a value in the graph where it is asymptote for the graph. So in this graph, basically your x cannot be 0. So when we are mentioning the answer, right, we can state that, oh, x is between -2 to +2, it will be increasing, but it is not included for the point x equals to 0.
This is one way that you can express your answer. Or maybe if you want, you can separate into two parts, because you can see quite clearly that for the first part of the graph here, it is decreasing from -2 until 0, but doesn't include the 0. Then for this part, it is from 0 until +2, but it doesn't include the 0 as well. Or you can write it in this way, separate into two different parts. So you're having -2 until 0, and after that, 0 until 2. Okay, all right. So this is how we decide where is the function decreasing. What's the range of x so that the function is decreasing. Okay, yeah. So let's continue to part B. For part B, a triangle is bounded by the x-axis, the normal to the curve at x equals to 1, tangent to the curve at x equals to -1. Find the area of the triangle. Give your answer correct to three significant figures. Okay, so for this question, basically I need to find out the normal to the curve first at x equals to 0, at x equals to 1, and also the tangent of the curve at x equals to -1 first. After that, I might want to find out the intercept for maybe all these lines and also the y-axis and see how they form a triangle with the y-axis. Then only we continue to find out the area. Alright, so first step, let us find out the equation of normal first. Okay, so to find the equation of normal, I substitute -1 into my function f prime x. So from here, I'm having -12, then plus 3, which is equals to -9. Okay, so just to recall back a bit, what is our function f prime x? So function f prime x is this one. This is the function f prime x. And then what is the function fx? So the function fx is this. I can't remember also. Where? Function fx 4 over x3. Oh yeah, okay. So 4 over x power 3 minus 3 over x, then plus 2. We might want to use this somewhere here later. Okay, so I substitute -1 into the function of f prime x so that I can get the gradient of tangent. This is the gradient of tangent, right? -9. And I want to get the gradient of normal. So the gradient of normal will be -1 divided by the gradient of tangent. Therefore, your gradient of normal equals to 9. And then we want to know also what's the coordinate of y when x equals to 1. So when x equals to 1, substitute into the function fx. From there, you'll get your y equals to 4 minus 3 plus 2. And the y that you get is basically a 3. After you get the gradient of the normal and also the passing point, then you can form equation of normal. Okay, so what's the equation for normal? Y minus y1 equals to m, then x minus x1. Simplify your equation. By right, you'll be having this as your normal equation. So 9x minus 9. Sorry, I make a careless mistake here, right? This one shouldn't be a 9. It should be 1 over 9. I'm so sorry. Then this part also the same. Okay, so 1 over 9. Okay, so if you try to simplify all these things here, you'll be having y equals to 1 over 9x and then plus 26 over 9. And this is my equation of normal at x equals to 1. And just now, according to the question, we have also another line, which is the equation of the tangent, the tangent at the point x equals to -1. So I also want to find out this particular gradient equation of tangent. So I substitute x equals to -1 into my calculation. So I observe another error here, this one. Higher. So this one should be a 1. Okay, but the answer here are all correct, yeah? I just make the value wrongly. Substitute the value wrongly. It should be a 1. Okay, so when x equals to 1, okay. Then now I want to substitute x equals to -1. into my equation of f prime x. If you try to simplify this answer, by right you're having negative 12 plus 3, which is negative 9. Okay, and therefore you know that this gradient of tangent that you want to use here is negative 9. Okay, all right. And after that, I want to know what's my passing point for this particular tangent line. When x equals to negative 1, what's the value of y that I get? So again, substitute negative 1 into this particular function. You'll be having negative 4 plus 3 plus 2. And end up, the answer for the y is a 1. You have the gradient, you have the passing point. So again, I want to form the equation of tangent. Okay, so if you try to find the equation of tangent, right? So you will be having this y minus 1 equals to negative 9. Then x minus x1. So it becomes x plus x negative negative 1. It becomes x plus 1. So your y is equals to negative 9x minus 8. Okay, so this is particularly what I have for the equation of normal and also equation of tangent. And now for this question, they actually want us to find the area of the triangle that these two lines form with the y-axis. If you try to read the question again, they want to find the area of the triangle where these two lines form with the y-axis here. Okay, all right, so maybe we need to observe a little bit about the graph, how the graph look like. Okay, so if I go back to our graph just now, the diagram just now. Okay, so let's say when I'm having x equals to negative 1 or x equals to 1. When x equals to 1 means that I'm having a point here. Let's say this is x equals to 1. Let's say, okay, so this is my x equals to 1. The tangent look here, so the normal will be something like this. Okay, so this is a normal at x equals to 1. Okay, then where is my x equals to negative 1? Alright, so if you try to substitute x equals to negative 1, by right, your diagram will be somewhere here, let's say. Okay, so if let's say you want to form the tangent, okay, the tangent of the line, it will look something like this. And then if you try to extend it, you will see that it will intersect here. For now, right, I try to extend all the line for normal and tangent so that I can see how they form a triangle with the y-axis. Okay, so I extend the tangent until it touch the y-axis. And then for the normal also, I try to extend until they intersect with each other. That includes the y-axis as well. So if let's say you look at the line normal and also the tangent and also the y-axis, right? The triangle that we are interested to find out is this one. So maybe I put it thicker, right? So this is a triangle that we are interested to find out. I want to find the area for this particular triangle. Okay, and then it is worth to mention that if you try to observe the gradient of the normal and also the gradient of the tangent that we found out just now, right? They are actually, if you multiply them together, you get negative 1. So it means what? It means that basically these two lines are perpendicular to each other. So that means this is a perpendicular line. Okay, all right. So you try to imagine this is a tangent where it is a straight line. What I draw here, it doesn't look like a straight line, but basically it's a straight line. Maybe I draw it again so it looks clearer. And I have to make sure that it intersects with the y-axis so that you can see a triangle in a clearer way. Okay, so in short, how is your triangle look like? It will be something like this. So you're having a line like that, then you're having a line like this. Not in ratio, this one is not in ratio, right? This is 90 degree. Okay, all right, so this is a normal and this is the tangent. Okay, so of course we are interested to find out the shaded area for this triangle here. Okay, so now I will want to bring this down to the next question. Okay, so let's have a look for this part now. Okay, so from here, I already successfully know that how the triangle look like. Okay, right, so I already know that my triangle looks something like this. And first, I think I need to know what is this point. Okay, and also what is the point here. I need to know what is the y-intercept for both the graph, both the line. Then after that, I also want to know what is the coordinate for the intersection point for these two lines. Then only I know how to find out the area of the triangle. Okay, all right. So I go back to the normal equation. For this normal equation, I want to find out the the y-intercept. So I let x equals to 0. When I let x equals to 0, then what do I get here is my y is equals to 26 over 9. Okay. For the tangent, also the same. For the tangent line, I want to find out the y-intercept. So also I let x equals to 0. Then what's the value of y that I get? So the value of y that I get is negative 8. Okay, all right. So for the particular triangle that I have, I already know two lengths here. Okay, so let's say this is a triangle that I have. This is 90 degree. Okay, so this particular point is the y-intercept for normal graph. So the coordinate is 0 and also the 26 over 9. Then for this particular point, it is a y-intercept for tangent graph. So the coordinate is 0 and also negative 8. Alright, so to find out the area of the triangle, there are many ways that you can find out. For me personally, I want to find out this intersection point also, so that I can use the length of the base multiply with the length of the height that I divide it by 2. Okay, so I want to find this intersection point. How to find this intersection point? You have to solve the equation of normal and also equation of tangent simultaneously, because these two lines intersect to get this intersection point. Okay, yeah. So now let me find out the intersection point first. So I let equation of normal, okay, equate to the equation of tangent. So from here, I try to solve that. If I try to solve that, right, I'm having 82 over 9x. You simplify it, yeah, equals to negative 98 over 9. Then when I get the x, I get the x coordinate negative 49 over 41. Okay, I know that this value looks a bit weird. For the first time when I try this question, I also feel shocked. Like, did I do any careless mistake somewhere else? Okay, then after I go through my step, I realize that there's no careless mistake. Then I double check again with the marking scheme. Then only I realize that, oh, okay lah, very likely my answer is correct one. Okay, so if you get this kind of answer, no need to worry. You just double check and make sure that there's no careless mistake made. Right? Okay, so when you get x equals to this value, then of course I need to know the y, right? So substitute this this value, go back into either equation of tangent or equation of normal, up to you. Then by right, you will get the y coordinate, which is 113 over 41. Okay, so if I want to plot it on my triangle here, this particular point is negative 49 over 41 and also 113 over 41. Okay, all right. Then now, how can I find the triangle, the area of the triangle? So to find the area of the triangle, I want to use half times base times height. And the base times height must be, the base and the height must be 90 degrees to each other. So maybe I will treat this one as my base. This length. Okay, and then the height maybe is this one. The length for this one. Okay, if I take half times base times height, then basically I successfully will get the area of the triangle. So let's start with the base first. Okay, so I just label this as base, easier for you to refer. Yeah, this is the base, and then this is the height. Okay, so what is the base formula? You have 2 points, right? You have 2 points here. I want to find the length for the base. So I use these 2 coordinates to find out the length for the base. Okay. Alright, so I've tried to find the base length. So the base length is you take x1 minus x2 square plus y1 minus y2 square. So this is x1 minus x2 square plus y1 minus y2 square. So you make this as y1 minus y2 square. So 26 over 9. Then you square it. Okay, so I'm using these 2 points. These 2 points here, this one and also this one. Okay, to find the length for the blue color base. Okay, alright, so the base length that I get is a long value. So I just try to write out long. Okay, after that, I want to find the height, the length of the height. So the length of the height is represented using purple color. So to find this length for this purple color line, I'm using this point and also this point, these 2 coordinates to calculate the length. Okay, to calculate the distance for these 2 points here. So the same thing happened. Okay, so x1 minus x2 square. Then y1 minus y2 square. So y1 minus y2 minus negative 8. It will become a positive 8. Then you square it. And the length for this one is 10.82228956. Okay, after I get the base, I get the height, then only I try to calculate the area of the triangle. So the area of the triangle will be half times base times height. Okay, then simplify the answer. I will get 6.51, correct to 3 significant figure. Alright, yeah, so this is how we get the area for the triangle in this case. Okay, so in my opinion, I think you need to roughly draw out how the triangle look like so that you know what is the correct point that you want to use to calculate the length and calculate the height or whatsoever. Okay, without sketching out the triangle, you might not able to see how the triangle look like, how the normal and tangent actually form the triangle with the y-axis. Okay, yeah, so for this question, it looks like a little bit weird, especially for all the values that we get in the x and y here. But basically, the concept wise, this is something that we can use. Okay, I believe that there are some other method that you can use to find the area of the triangle here. Okay, so for this is one of the suggestion that I use here. All right, so this is the last question for this paper. All right, thank you very much for watching the